In this video lesson, we're going to be learning how double replacement reactions work inside of aqueous solutions. Based on the model above, we can see that the metal A and the metal C are swapping partners when they are dissolved together into solutions. This makes brand new products on the other side of the equation. Looking at our first problem, we have sodium hydroxide and we're adding it to magnesium chloride. Now, when we do this, we have to first identify the metals. The metals are swapping partners with each other. This means that the sodium is binding up to the chlorine and the magnesium binds up to the hydroxide. It's also a really good idea to figure out the oxidation charges of everything first, so that way we can rewrite our products as sodium chloride and magnesium hydroxide. Now, using reference table F, we're going to look up our halides. We can see they're all aqueous, meaning it dissolves into sodium ions and chloride ions, but hydroxides are all insoluble, especially with magnesium. This forms a solid. Another equation we're going to look at is what happens when lithium phosphate is being added to iron chloride. Now, both of these are aqueous to begin with, but when we mix them together, they're going to probably form a precipitate. Again, step one, figure out the oxidation charges. Now, we could see lithium is a positive 1 charge, phosphate is a negative 3, the iron is a positive 2, and the chlorine is a negative 1. This means when you swap partners, we're going to make iron to phosphate, and we're also going to be making lithium chloride. Next, using reference table F, we check out our phosphates and our halides, and we can see all phosphates are insoluble, that's our precipitate, while our halide is going to be aqueous, which forms lithium ions and chloride ions. Another practice problem involves ammonium, NH4, and it's being mixed with our chromates. So ammonium chromate is being added to potassium iodine. Now again, the ammonium is our positive 1 charge, and since there are 2 of them, we can see that our chromate must also have a negative 2 charge. Potassium is going to have a positive 1 and iodine will have a negative 1. So when they swap partners, we're now going to be making something called potassium chromate, and we're also making ammonium iodine. Now, when we look at reference table F, we're checking out our chromates. All chromates are insoluble unless the element is in group 1. So we could see in both of these, for our ammonium iodine and our potassium chromate, they're both going to be aqueous, meaning there's going to be no precipitates formed in this reaction and everything was ions. In our last practice problem, we have rubidium iodine and lead 2 nitrate. Again, figure out what the different oxidation charges are. Sometimes it's always good to do the constants like elements and polyatomics first, and you can see that we make lead iodide and also rubidium nitrate. Now, lead iodine is going to be our solid because it is a halide and lead 2 ions form precipitates, while rubidium nitrate is going to be fully aqueous.